when you did the front of that green worksheet, it had you list the number of triangles that was in each shape. And then it had you list how many degrees was in each shape. Did you see a pattern? Okay, what was the pattern, Stella? Just like in that very right-hand column, what happened every time?
60. Oh, that's what I meant.
Okay, it went up by 180 degrees. So every time we added a new side, there was another 180 degrees in the figure. Now, if I wanted to know how many degrees are in a certain shape, what do I need to multiply 180 degrees by? Okay, the number of triangles, which is not the number of sides. It's the number of sides minus 2. Okay, so on that front side, we should have figured out that the sum of our interior angles, the number of sides minus 2 times 180. That's going to happen every time. Okay. Wasn't that nice to kind of see the pattern though? Isn't geometry so cool? Okay. We have cool patterns happening all the time. Okay. Now, before we do an example, I do want to remind you of some vocabulary terms. Okay. Now we're going to focus on quadrilaterals specifically starting tomorrow. But today I might ask you for different sizes of polygons. Okay. So up here, I'm just going to have you, if you need to, let's remember that 3 sides is a triangle. 4 sides, we call a quadrilateral. 5? Pentagon, like that famous building in Washington, D.C. 6 is a hexagon. Aiden, do you remember 7 sides? Heptagon.
Octagon.
We all should know octagon, right? We see them every time our parents drive us somewhere. A stop sign. Yep. Next time you see a stop sign, count the sides. Okay. 9. Nonagon. When Ben is back. 10. And 12. Dodec. I'm impressed. There are a few of you that really remembered these. 11agon. Anything that's not up here, we would just call like that number gone. So like 13 gone, 16 gone. Okay, so these are words that you need to know so that if I say, hey, what's the sum of the interior angles of a heptagon? You know what the heck that is. Okay. Do you not know them?
Wait, do we need to know them?
I don't know heptagon or
I don't know. Okay. It sounds like everyone's done writing these down, so let's come down here. Bryce, pick a polygon. Pick a cooler polygon. Okay, a dodecagon. If I want to know the sum of the interior angles of a dodecagon, we don't even need to do that. How many sides does a dodecagon have?
12.
So we're going to take 12 minus 2 and multiply it by 180.
Yeah, I had to read that. That was an 8.
So that's A, that's the formula. B, this takes into account how many triangles there are in that shape. Because we have to like take two of the sides to make a triangle and then everyone from there. Like, see? Okay. Now, what if I wanted to know? What if I wanted to know each measure of a regular dodecagon angle? We're not gonna worry about that right now. Okay, Gavin, divided by what? Okay, so how many angles are in a dodecagon? Oh, okay, so I'm going to take 1800 degrees and divide it by 12. What is that?
It's 90.
It's 90? I don't think so.
Yeah.
What? 150? That may not be right. Aiden? Ooh. Layla coming in clutch there. Well, Layla said 150, you double checked her. Okay. Okay, now on the back side, you looked at the exterior angles, okay? And no matter what shape they gave you, when you added up these 3, 4, 5, whatever, right here, what did they add up to be every time? Okay, our exterior angles are always going to add up to be 360 degrees, no matter what. So since they form a linear pair with our interior angles, like the bigger as we increase the number of sides, we increase the amount of angles that are inside, but then that also like decreases these exterior angles. Okay, and they're just always going to add up to be 360. Okay? It's actually pretty cool in my opinion. I know, but I think things are cool that you don't, so it's cool. So I want to look at page 199. Okay, I don't look at number 4. What did I tell you? There's 900 degrees inside of the polygon. I want to know how many sides it has. Okay, raise your hand. Raise your hand. How would we set that up without looking at your chart? How would we set it up? So 900 divided by 180 gives us what?
5.
So it's a pentagon? Okay. So this is what I want to, I like that you said let's divide by 180, but that's not going to give us like the exact number. Hold on. Let's talk about why we need to add 2. So the number of degrees that these add up to be should equal n minus 2 times 180. So when Addie said, let's divide by 180, if we're going to solve that, that's a reasonable first step, don't you think? So now we have 5 equals n minus 2. So we're going to add 2. And we have a heptagon. 7. Hexa is 6. Hepta is 7. Like an octopus. Nonagon. Decagon. So you know what a decathlon is, right? In like in the Olympics, it's like a 10 event Olympic or track event. So gotta think of that for 10. Okay. All right. Now, what if I gave you something like number 8? Okay. First of all, how many sides does this have?
6.
6. So if we take 6 minus 2 times 180, how many degrees does this have? 720? 720. So solve for x. Solve for x. Go. X is not 180. I can tell you that.
690, right? See, even it is 190.
What did I tell you, Jack?
I didn't see the right. I missed that right.
190.
Should be 90.
All right, our row is getting 90 degrees.
I got a
190 does not make sense, my dear. Our angle, since this is a convex polygon, all of our angles will be less than 180.
Oh, yeah, that makes sense.
Concave is in, convex is not.
This is convex or concave?
This is convex.
Well, then I thought if it was convex, all the
Convex would be, concave would be that. Where it's like caved in, concave. This one is not. This one's not caved in. This is convex. Okay. All right, let's talk about number 10. What do we know about the 4 angles that we have marked in number 10? They add to what? 360. Every time your exterior angles will add up to be 360. X20. You disagree? Oh.